Hello, and welcome to Introduction to AWS CodeArtifact. My name is Richard Boyd. I'm a Senior Developer Advocate for AWS's Developer Tools. So this includes our code suite, which includes code build, code artifact, code commit, code deploy, code pipelines, as well as our SDKs, our CDK, our CLI, and our IDEs and toolkits, including Cloud9. Today, we're going to talk about a new service we just launched, AWS CodeArtifact. It's a secure, scalable, and cost-effective artifact management for software development service. And I'm really excited about it, and I hope you will be too. So let's start with the agenda. First, we're going to cover what is an artifact repository. Then we'll talk about some of the challenges that exist with current solutions. And then I'll introduce kind of how AWS CodeArtifact solves some of these problems. Finally, we'll wrap it up with a getting started. We'll walk through a quick demo showing how to create your first repository, and then we'll open it up for Q&A. So what is an artifact repository? Now, an artifact repository service manages your end-to-end artifact lifecycle and supports different software package management systems. The key benefit for developers is to make third-party software automatically available for use. Automated importing eliminates the manual or semi-automated imports commonly required to make third-party software available. There's many definitions of what an artifact repository is. And I think this one kind of hits the core bits of what an artifact repository should do. If we think about it, the software development lifecycle, we've got the phase where we author code, we store it in some kind of source system such as code commit, Git repository, which could be on Git or GitHub, Bitbucket, GitLab, any of these other Git-based or source control-based systems. And you'll check in files. It could be a .java file if you're using Java, .py, .so, depending on the language you're using to develop it. This is generally where code review happens, using like branching mechanisms to say who can or can't merge in code and controlling what code makes it onto your main branch of your repository. Next, we've got the build stage. So the build stage is what compiles your code. It runs the unit test. When you're writing your code during the source and authorship, during the authorship stage, you would generally also write the unit test, but the build stage is what ensures that those tests run. This also runs style checkers to make sure that you're using tabs or spaces, whatever your team prefers, that there's no dangling new lines at the end of the file unless you're using Python, in which case it's required. And then it also creates container images, functional deployment packages that are dependent on the application that you're building. So this might be a Docker image. It could be a jar file. It could be a packaged up Python distribution. It could be any kind of functional deployment package. And then it's tested again after that with the integration tests to test it with other systems. Sometimes this is called end-to-end testing, integration tests, component tests. You do load testing, which is more of a performance-based testing. UI testing is often done at this point, and also like security testing. So you might have some kind of security fuzzing tool that'll poke around some inputs to make sure that it's not accepting bad or garbled inputs and behaving inappropriately. And then finally it goes into production. When I talk about it going into production, this also includes all of the pre-production stages as well. So this is typically you'd have a beta and a pre-prod or an integ or integration stage before prod. But in this scenario, we'll just call it production, and we'll just assume that that includes your pre-production stages as well. It's the deployment part of the software development lifecycle. And in this stage is when you monitor the code to see how it's behaving in quote-unquote the real world to make sure that you're catching if you see a rise in 500 errors or a rise in 400 errors or a drop in 200s maybe. Sometimes people refer to this as dogs not barking. If typically you have a lot of successful requests and then you just have no requests whatsoever, it's also a thing you tend to want to monitor and observe. And then separate from this, we've got documentation, which could be stored with your source. There's tools like JavaDoc that'll store this kind of inside your code and then automatically extract it. And then there's the compiled. And you have your compiled applications, which are, like I mentioned before, the jar, but plus all of its dependencies. Your .so file, all of your compiled files, like packaged up into some deployable unit. And then the actual like deployed package. So all these taken together, these are what we call artifacts. Right? And this is a thing that if you use some other package publishing tools, it'll encapsulate all of these artifacts and then like make them available generally as a zip file. And you can share these with however you want. You can put them on a public registry such as npm.js or PyPI or Maven Central. And other people can download them. They can, depending on the registry, you can pick if you want the documentation to come with it or you just want the application. Usually if you're doing like development work, you would use like a dev version that has a documentation and more verbose contents of this so you can check for the methods that a file needs, the parameters that a method needs. I'm sorry. But then when you deploy to production, that's not really needed. So typically there'd be like a trimmed down version that's also available. Not every language or package manager supports like offering both, but some do. So it's good to just mention that this is a thing that sometimes happens, is available. So where an artifact repository is really useful is in this source and build stage. So you have a source code repository, right? This is something like code commit, GitHub, GitLab, Bitbucket. And you check in your code, you do a build, and then you want to do something with those built artifacts and put them somewhere. And this is what an artifact repository is for. It takes your built artifacts that you've already run all of your unit tests against, and you said, okay, this passes all of my unit tests. I think it's safe to test. Now, I'm not sure if it's safe for production yet because we're going to put it through the test stage, but I know that it's safe to at least test. It's functionally complete. I'm ready to move forward with this. You could kind of store it in like a Git type repository if you wanted to. You would lose a lot of the features that an artifact repository gives you, so most people don't do that, but it is possible. We see this sometimes in things that are called vendored requests. Specifically, if you're extremely worried about the availability of a dependency at some point in the future, sometimes what a package will do is they'll say, okay, well, I'm going to pull in this package and I'm going to say, okay, this entire third-party package is now like part of my package that I'm going to control when it's updated inside my package, and I don't have to worry about it not being available anymore. That is one way where people use source code repositories as a type of artifact repository, but it's the exception rather than the norm. Vendoring requests brings up security and safety of these packages. There's additional concerns outside of just storage when it comes to a package. I might want to be able to say I don't want anyone to bring in a package that has a license that's not approved inside of the organization that I'm in. Or there was a famous incident a few years ago where someone took the package from a public package manager and deleted it. They said, I don't want this to be used anymore. I'm just going to unpublish this and no one can use it. But it was very deep in the dependency tree of many other thousands of packages. And the package manager had to make an extremely tough decision to say, what we're actually going to do is we're going to take an old version of this and republish it to make it available because it just broke so much stuff with this package not being available. If you're running a business that's based on some of these packages that might have a very permissive license that says, hey, you can use this in your business. But if someone takes the package and leaves and makes it unavailable to you, it makes it very difficult. It adds more uncertainty to your development process, and it's a problem that you'd like to avoid if you can. So your options are to find some way to save the package, to create your own backup system, or to implement and maintain that package by yourself. And because that package probably isn't your core business area, it would be somewhat like a distraction and not the best use of your resources. So this is where something like an artifact repository does very well, because you can be certain that you know exactly what version of what package will be pulled into a build at any given time, and you know that the package will be available because you control the repository. So let's quickly talk about some challenges with existing solutions. First, you have to set them up. So there's some that run as software as a service that lives on a server that you maintain inside of a data center. It could be in a cloud, it could be in your on-premise data center, but you have to provision this virtual machine or this actual physical server. You have to install the operating system. You have to make sure you apply security packages to it. And this again, this distracts from kind of like your core business stuff. Very few people are in the business of running a package repository. So anything that you have to do to manage your package repository is just pure overhead, something that you would much rather just not do. Some of these package management solutions require either upfront fees or commitments to spend a certain amount. They have very steep licensing fees that can run up into the tens of thousands of dollars per year. If you're just trying to feel out kind of how much you really need a package registry service, that first step of signing a $10,000 contract for 1 year is kind of a big step, especially as a small company. And what we've seen is many companies, just especially small ones, just don't do any kind of package management. They just say, you know what, like we have bigger concerns that aren't the availability of some package. We're just not going to worry about it until it becomes a problem when we do have to worry about it. Which brings us to our third point of just the durability of these third-party packages that you consume. As I mentioned earlier, there are cases where someone could just unpublish their package. So if you're relying on a third-party or a public registry to host your packages and someone unpublishes it, the package is just gone. The next time you run a build or try to install it, it won't be there. And then maybe you can recover it from a previous build, but you're going to spend a bunch of time trying to fix this. And then finally, it's the safety. If you tell your developers, hey, you can use any package on PyPI or npm.js or Maven Central or some other public package manager, you generally have to put in some pretty strict security constraints. They tend to be reactive, where you see what has come in and then make some changes, have someone audit it, or you have the developers require 2 or 3 developers review any packages that are pulled in to say, should we take a dependency on this or should we not? In addition to that, so separately from that, what some companies do is they say, okay, you have to contact security. Security will do this process, and they act as a type of gatekeeper to make sure that no insecure packages come in. This slows down development, and it just adds more friction, and developers tend to either just kind of copy the bits of code that they can, that they need for what they're trying to do, assuming that the license allows that, or they kind of write their own version of it that's not as well tested, not as well maintained, but accomplishes the same functionality. Or in the absolute worst case, someone will just kind of import it on their own and not tell anyone if the security controls aren't correct. All of these lead to distractions as a business owner or someone trying to run a business. So it'd be great to have a managed service that does all of this for you, and then you can focus on whatever it is that brings your business value. This is why we created AWS CodeArtifact. It's a fully managed artifact repository service. And when we say it's fully managed, what we mean is AWS controls and maintains, updates, and patches the actual physical hardware that the service runs on. And all you have to worry about is just making sure you hit the right endpoint with the right credentials, and that your packages will always be there. You can rely on the SLA guarantees that we provide as part of the terms of service, and there's nothing else that you have to do to ensure that the artifact repository is available and ready to use. It supports the Node package manager. It's called NPM, Maven for Java, Python packages in pip format. We've received a lot of requests to support NuGet, Ruby, CocoaPods, some other fairly common ones, and we are working on these. But these are the 3 main ones that we support today. It works with Maven, Gradle, NPM, Yarn, Twine, and pip. Twine and pip are both used for Python. One's used for pulling, and the other one's for publishing packages. And then we offer a pay-as-you-go pricing structure with no upfront license fees. So you don't have to commit to using it for a year, commit to spending a certain amount of money. You can say, hey, I'd like to create a repository, and you only pay for what you use. And later we'll cover the billing aspect of kind of how much this costs and how to compute what the cost is. So a very high-level overview of what CodeArtifact is that here on the left we see public artifact repositories. These are things like npm.js, PyPI, Maven Central, and this is where people, if you're on a computer and you run pip install and install some package, it generally pulls it from this public endpoint. Inside of CodeArtifact and inside of your account, you have what's called a domain. A domain is just a logical grouping of repositories, and we use a domain as a boundary. So any artifact that's stored in the domain is deduplicated with any other identical artifact. So for example, let's say that you use the Python request library. It's one of the most popular third-party libraries that's installed. And you have requests, let's say version 2.0.1 and 2.0.2. And between those two versions, only one file was changed. Let's say it was a very small bug fix, one line, only one file was changed. And let's say there's 30 files in the entire package. All these numbers I'm just making up for the demonstration. I don't actually know how many files are in this particular package. When we deduplicate the package, the 29 files that are common between those two versions are only stored once in the domain, and we can have a pointer that points to the separate versions of those. And then the two single files, which represents the difference between those two, are each stored one time. So if you have 2 or 3 or 4 or 5 versions of a package, you're not storing 2, 3, 4, or 5 full copies of the entire package, which cuts down on how much you would have to store. And because storage volume is one of the dimensions that we perform pricing calculations on, it ends up being cheaper. And then on the right-hand side, we see what we have. You can pull application dependencies for development. So this could be a developer who's working at their workstation and they want to pull in all of the dependencies that their production application needs so that they can test it locally. So they'll interact with the CodeArtifact repository directly or the domain directly. And if there's a file that's not present, if there's a package that's not present in the repository, you can configure it to go to public repository and pull it in if needed. You can also say, I don't want public artifacts in there, and you can turn that off if that's what's appropriate for your business. Separate from that, you can use CodeBuild, which is our managed build environment, or any other CI/CD system. So if you're using Jenkins or TeamCity or Circle CI or any of these other CI/CD environments, because you're using the same package managers you're already using, so pip, Maven, npm, you can use the same tools that you're already using in some of these other tools. So you're not locked into just using CodeBuild. You can use any build system, any deployment system you want. If you're already using pip install to install some requirement, you can use CodeArtifact the same way. You just add a setting that's in like the pip settings to tell what repository endpoint to point to, and as they say, you're off to the races. Let's talk about developer tools for modern software delivery that AWS provides. Start with AWS Code Pipeline, which stitches together your source, build, test, and production stages, so you have a single place to see your entire software delivery process. We also offer tools for making it easier to author software. This is AWS Cloud9, which is our cloud-based integrated development environment. We also offer IDE toolkits for JetBrains products as well as VS Code, which are plugins that you can put into these IDEs that allow you to more seamlessly integrate with your AWS resources. We offer AWS Code Commit for storing your source. It's a Git-based software version control system. And we offer Code Build for building your applications and running your unit tests, or if you just want to do a build. And then for testing, you can use Code Build to run the tests. We integrate with third-party tools that run load or performance tests. And finally, you can use Code Deploy to deploy your artifacts into production. And CodeArtifact spans all of these. So when you're using Cloud9 or you're using whatever IDE that you enjoy using, whether on the cloud or on your desktop, you can pull artifacts from AWS CodeArtifact. You can, if you wanted to push some artifacts to a test CodeArtifact repository, in your build stage obviously needs to be able to pull in dependencies, so it integrates with CodeArtifact. In the test stage, you may want to pull some other package to do some testing. Maybe you use a third-party package to actually perform the test, and you want to store that third-party package in CodeArtifact. That's fully supported. And then today, Code Deploy doesn't natively interact with CodeArtifact. I don't think that it's necessarily a quote-unquote deployment process. Typically, your build or your test phase is what would put it into CodeArtifact. We are working with some customers to see kind of how that interaction would play out. If you are interested in using Code Deploy with CodeArtifact, I'd love to hear from you. We have people in the chat who will can collect your information, and we'd love to hear more about your use case. So some of the features of CodeArtifact allows you to easily create and manage artifact repositories. You can have as many repositories as you want. So say you've got one domain, you can have 1,000 repositories in it that all have the same package. So it's 50 packages, each stored in 1,000 repositories. Instead of storing 50,000 copies, we'd only store one copy, but we handle any kind of deduplication across those. So as a user, it appears that you have your own private copy of this, but they're actually in S3 storage system that we use under the hood. You're getting that 11 nines of durability, but without having to pay to store the same file, the packages, 50,000 packages. As I mentioned earlier, with it being fully managed, there's no need to configure, patch, update, or manage your own artifact repository or even the servers underneath them. It just runs. So it's an endpoint that you hit with an API, with the credentials, your AWS CMD4 credentials that you already have, and it quote unquote just works. It's integrated with KMS, which is the AWS Key Management Service, and AWS CloudTrail, which allows you to see any interactions that have happened with your repository. So you can ensure that your packages are encrypted at rest, so they're always encrypted. Because KMS allows you to bring your own key or use a KMS managed key, you can say, I know that AWS can't possibly read my packages because I have the only key to decrypt it, and no one else does. Or if you don't want to have to delete many things, but you want to be able to make some guarantees that no one else can ever get to them, you can just delete the decryption key associated with it, and you know that all of those packages are essentially useless now as a way of deleting or lifecycling out all packages. And because it's integrated with AWS IAM and the resource-based policies, you get that fine-grained control that IAM offers. So you can say, this person is allowed to publish packages that only packages start with this name. So you can use namespaces that Maven supports, and believe NPM supports as well, to say, okay, this person or this team or this group can only publish into this namespace, or they can only consume from this namespace, so that you have very fine-grained control over who has access to what packages. It also reduces your operational overhead. I've mentioned a few times, but you can never mention too much. It is fully managed, so you don't have to worry about hiring more IT staff to manage the servers to support this package management system, and it's highly available. We're built on top of it. S3, which is a super durable data storage service, it automatically spans across multiple availability zones. So we do offer SLA guarantees about the availability of the service. So some of the other features that it provides, as I had mentioned before, it works with your existing package managers and build tools. So if you're using Circle CI or Jenkins or TeamCity or some other third-party tool to interact with your package manager, you don't have to make any changes. You can, like I said, give it the new endpoint, add in an AWS command to supply the credentials, and you're set. 2-line change, and you don't have to worry about replacing your build system or being locked in because you're using a specific package manager. It uses the same package managers that you most likely already use. We also offer this feature that I mentioned before that automatically downloads dependencies from public artifact repositories, such as NPM registry, NPM.js, Maven Central, PyPI, things like this. You can enable or disable this feature however you want. You can say, okay, you can only pull in packages from NPM and Maven Central, but not PyPI or any combination of those that you want. And you have full control over how these packages come in. You support private access through VPC endpoints. So you know that when you request a package, it'll never leave the Amazon data center if you're already in the data center. If you're using a private, a direct connection to connect to the VPC, you know that your request will never touch the public internet. There are customers who have security constraints that is very valuable to them. And again, as I mentioned before, you get this granular access control and cross-account sharing that IAM offers. So I can say, I trust this other account, which is maybe it's the account that I use for testing, can publish, but only into my test repositories or only into this specific namespace within these repositories. And it's the same access patterns that you use for the rest of your AWS infrastructure, so you don't have to learn some new access control mechanism that's specific to your registry. It's you need to reuse a lot of those bits of information and best practices that you use elsewhere. You can encrypt your packages with your own KMS keys. AWS can provide you a KMS key. You can use the AWS managed ones if you want it encrypted, but you don't care how. There's several options here depending on the security posture that you're looking for. Almost guarantee that we'd have a KMS setting that accommodates that. You can also provide access logging and auditing with AWS CloudTrail. So you can see, this person, this user, this role or group, like attempted to access this and their request was denied, or they attempted to access this and it resulted in a new package being pulled in. Because it's integrated with CloudTrail, you can see all these events. So if you have a very strong logging and auditing requirement for something like SOC 2 or Sarbanes-Oxley, you can ensure that that requirement is met by using CloudTrail. And we also integrate with Amazon Event Bridge so that you can build these fully automated workflows. So once a package is published, you can have it kick off some kind of third-party scanning solution, or you can have it kick off a pipeline to start your deployment. I believe we cover that a little bit later, so I don't want to talk about it too much, but it is integrated with Event Bridge, so you can build like an event-driven system on top of your package management system. Okay, so I've mentioned a lot of parts of this, and I like to just cover some of these concepts just to make sure that they're very clear. So the first one is a domain. As I mentioned before, a domain is just many repositories. It's owned by a single account. It's referred to as the domain owner, and it is the logical unit in which we deduplicate packages or artifacts within a package. So a package is a collection of artifacts, which we'll get to in just a moment. But the domain is the boundary we draw around that says, okay, this is a logical unit of repositories. Next is a repository, and this is just a set of package versions which map to a set of assets. These assets are the things that we deduplicate across the domain. Now, we went back and forth and we asked a bunch of people, is it a repository or a registry? Like, what do we want to call this? Because if you say repository, people think of like a Git repository. So they think I can only have one published package in this, and it's all of its versions. But with CodeArtifact, you can not only have like many packages in there and many versions, those packages can be from many different languages. So you can have a single repository that stores your Maven artifacts, it stores your PyPI artifacts, your NPM artifacts, all in the same repository. If that's the logical unit that makes sense for your team. We think that most organizations only really need one domain. We use CodeArtifact internally inside of Amazon Retail, and we use a single Amazon domain, and we have many hundreds of repositories within that. We think that most companies could probably get away with many fewer, say a handful of repositories, maybe a dev, test, and prod, or functionally maybe they're finance and HR and engineering repositories. We don't think that customers would need many of these, but there are no actual, let's say, limits on these. Of you can have, I believe the current hard limit is 1,000 domains in an account. We can raise some of those, but if you're getting to that point, we'd like you to reach out to us. Like I said, we have people in the chat. If you ever encounter this situation, that we'd like to hear more about, like the use case that led to that, because we might need to revisit some of our assumptions. So we allow you to have many of both of these, but we don't think most customers would actually need that many. And like I said, I'm happy to be proven wrong on this. I just can't picture use cases where that's true. So coming back from my tangent, the next concept to discuss is a package. And this is just a bundle of software together with the metadata required to resolve the dependencies. So if I go back to my example of the request library, it's got all the Python files that support the actual functional using of the Python request library, but it also includes something like potentially a setup.py file, which includes the author, the license. Usually the license file is included in the package. This is the things that are described in like the metadata about the package that's used, and that's stored with the package. Next is an asset. An asset's like an individual file. In NPM, this is just a single .tgz file. In Maven, it's a POM and a set of jars. I think Python, it's a couple of zip files and some other metadata. And these are things that we deduplicate and store across your domain. Finally, we have an upstream. So when we say that one repository is upstream of another, we say that you have one code artifact repository and you can have it be upstream of another, which means that if you make a concrete example, I have repository A and upstream from A is repository B. This means that if I make a request to A and my package that I'm requesting is not there, it will go to B and try to resolve it from B. B in turn may have another repository upstream from it, and it'll either find the package at the end of this set of upstreams, or it won't, and it'll just give you the same error if you try to install a package. It just didn't exist. We treat public upstreams, which we call remote connections, slightly different than code artifact repository upstreams. So you're allowed to have, I believe it's either 5 or 10 upstream code artifact repositories, but you're only allowed to you can have either code artifact upstream repositories, or you can have a remote connection to a public package manager artifact repository. You can't have both. We do have a mechanism to make it appear as if you have both. So that particular constraint, we don't see it affecting many people, but it is something nice to be aware of if you're trying to troubleshoot or design how you want your upstream system to look. And we'll discuss this when we go through the example. So let's talk about how to use code artifact at a high level. First thing you'd want to do is create a domain and an artifact repository. This is done outside of your pipeline. Like I said, this is only done, a domain you should only have to create once per AWS organization that you have or per company. An artifact repository may be created about a handful of times, but this isn't something you would do fairly often. I just want to cover it here because you need it to get started. The next step is to configure your package manager clients to connect to the repository. So all the package managers that we support the reason that we're able to support them is because they allow you to define a custom endpoint to reach. This could be a internally managed version of PyPI, or it could be public PyPI or a private version of NPM, or whatever you're running. So in this example, we're talking about Python. We have an AWS CLI command to get a token. This is an authentication token. This replaces, in pip that you would need, is your username and password, because pip uses basic auth to authenticate requests. So we translate your IAM credentials into credentials the package manager speaks. Because these package managers speak many different credential processes, we provide a mechanism that'll swap the common IAM credentials you're already using for credentials that the package manager itself speaks. Then the next step, we set the global index. This just tells pip where to look to go get a package. And in the alias that we have here, it's connecting to a user named AWS. The token is the password because this is the way that the pip protocol works. And at your domain, which we provide that name for you, and then the name of the repo. Simple on the end there is part of the spec. I believe it's PEP 508. There's a Python PEP spec saying what this URL should look like. And that's where we define how we translate one set of credentials for another. And then finally, you just run your package manager commands the same way you always would. So you can add in these two commands, at the beginning of your build script in Circle CI or Jenkins or TeamCity or GitLab or GitHub Action, and it'll just work. As I mentioned before, Code Artifact integrates and interoperates with other systems. So you can use it with third-party CI/CD systems. It works with your CI/CD toolchain that you're already using. So like I mentioned before, you add in those two commands, everything else is the same. There's no custom software you would have to install. There's no proprietary package manager you have to download or version or purchase a license for. It just works with the tools you're already using. Because we integrate with EventBridge, you can get state change events that are sent to EventBridge. We send these events to EventBridge on your behalf, and you can listen for these events and say, did someone attempt to delete a package? Did someone attempt to import some package that had some properties? And you can use the EventBridge rule pattern to match on that to, maybe you want to notify a person that this isn't super important, but I want to look at it later. Or, if this happens, kick off some automated workflow. Maybe you want to scan the package and potentially remove it if it doesn't meet some kind of, licensing or other requirements. You can add your own rules on EventBridge to define what these actions are. For example, you can have a package version that when someone uploads a version, it'll trigger your code pipeline. Your code pipeline will start a release of your software with this new package version. So a question that comes up a lot is, kind of how is CodeArtifact different than other storage solutions that AWS offers? The most common one being S3. If you look at just the price, if I just stick all my artifacts in S3 or I stick them in CodeArtifact and don't think about anything else, it might appear that CodeArtifact is more expensive. But when you start talking about having a large number of packages and the deduplication we provide for you, there's a point at which those costs cross. And it's actually cheaper to use CodeArtifact and leverage that deduplication process. And CodeArtifact is part of this purpose-built, domain-specific storage solution that we've seen people asking for. So the same way you could store your Git repository just directly in S3, or you could store your Docker images in S3. You want a tool that works with your Docker client, or it works with your Git client, or it works with NPM. And you don't want to have to write your own shim that kind of translates S3 storage to whatever this client-side tool is. So if you have a container image, you build some image, make it available. We offer ECR for storing that. We have code commit for storing your source code. If you have static files, big blobs of just objects that you want to store, it's hard to beat S3. It's super cheap, super durable, highly available. You can't go wrong. I mean, that's why we built CodeArtifact on top of S3, because it's so reliable. And then finally, we have CodeArtifact for when you want to store these built packages, when you're really concerned with, I want to see this version, I want to see the README that's associated with the version, I want to see the license that's associated. There's a lot of these things that you want to see that are specific to the context of a package that CodeArtifact provides to you. Then you'd have to write your own kind of shim to see if you're using something like S3 or some other kind of blob-based storage. Now that we've covered a lot of the theoretical or some of the talking points about CodeArtifact, let's get into an example of actually using CodeArtifact and how you would set up your first repository. So I'm in the AWS console. I'm in the US West 2 region. We launched in 10 regions. We received a lot of requests to launch in additional regions. We are working on this. If you have a specific region you'd like to use it in for a data sovereignty issue or for a latency issue, again, we have people in the chat. I'd love to hear your use case. I believe my contact information will also be added to the slide for people who watch this after the fact. So we're in the Oregon region. This is the landing page where we're going to create a repository. All right, so it's asked me for a repository name. So I'm going to call this Richard's repository. Very creative name. Description is optional. This is the public upstreams. So I enjoy using Python, so we're going to integrate with the public PyPI, and let's say NPM. That's my second most commonly used one that I use. You can pick all, none, some of these. I'm going to pick these two just to show kind of how this looks. Next, they'll ask for the domain. So where do I want this repository to live? So I can say it's a domain in this account, or if it's in another account. We offer this cross-account experience if you need that. We're going to say this account, but there isn't a domain created in this account, so it's going to ask me to create one. So let's create a domain called Richard's domain. Also very creative. And then this is the domain URL it creates for us. We don't have to save this. It's going to show it to us again later if we need it. And here's where I would choose to encrypt how I want to encrypt my data. Your data will always be encrypted at rest, but we give you the option here of controlling kind of how it's encrypted. AWS manages the encryption, but they'll let me manage it. For this demo, I'm just going to let AWS manage it, but the option is there if I wanted to provide my own key. So this is what it's going to create. It'll create a domain, and this is just a review before it actually creates it. Creates a domain, creates my Richard's repository, and it creates two upstream repositories called PyPI store and NPM store. So my repository that I'll interact with has two upstreams that are part of CodeArtifact, which are called PyPI store and NPM store. And each of these individually has one external connection to the public version of their repository. This is what I mentioned earlier, is that we have that limitation of you get either a code artifact upstreams, multiple of those, or one external connection. But there are cases where you want both. We support that. We set everything up and connect everything for you. And because we deduplicate across the domain, if you attempt to install a package in this repository, let's say we're getting it from pip, it will go to this upstream. It will see that it's not available. It'll go to the public pip repository, get the package. It'll store it here and then copy it here. So now we have 2 copies of this, but we're only charged for one version of it because CodeArtifact deduplicates those assets across those. So there is no extra charge for this. It's not some kind of a scheme to charge more or build more resources. It's just a technical limitation for how some of the proxying system works. And then there's a more detailed description of it's going to create this repository. If a domain already existed that we connect to, it would have a description here. Let's say create repository. We'll give that just a moment. And it is created. So we get these connection instructions up here. If you're like me, I close these as soon as they show up without even reading them, or I'll read them right at the last moment, not realize I've lost my instructions. We also offer them in this button here inside the repository. So I'm going to back out of this. So let's say I've created this. I go off, I go to lunch, I have a party, I come back, and back at CodeArtifact. So when this is the landing page we would see if there are no repositories, but because we created one, I believe what's the default? Default is this repository. So this is the one that we will be interacting with, and these are the upstreams that are used to proxy connections to public connections. So I go open this one up. I'm like, yeah, I made this days ago. I don't remember how to connect to it. Please help. There's some information in here that describes this, but there's also these connection instructions. It says that you'll have to use a version of the CLI that has the CodeArtifact resources in it. So if you use the most recent of either our V1 or V2 CLI, you'll be fine. And then you say, what package manager do you want to use? NPM, Maven, Gradle, pip. Let's just say pip. And it gives you 2 options. So there's like the automatic one, which is this AWS CodeArtifact login. The tool is package manager, and then the repository domain name, and you're all set. If the repository is owned by the domain, like the domain owner is the repository owner, you technically don't need this. If you don't need it and you supply it anyways, nothing will happen. We just put it in here out of abundance of caution. So if you run this command, this will automatically set the settings for you in pip. So this is the only command that you have to run. If you're not comfortable with the AWS CLI, creating or updating files in your pip package manager, there is a manual way to do this, which is the 2 steps I described earlier. So you can export this token where it gets the authorization token, which is what happens inside of this login command plus some other stuff. And then this token is essentially just a password that's used to access pip. And then you can use pip to manually set this file if you don't trust the AWS CLI to change it for you. You can copy any of these out and paste them into your CI/CD system, and then you're set. You can use this to fetch packages, to publish packages into it, and now we have our first repository. Okay, and that wraps up our demo, as well as it wraps up this session. I'd like to thank you for attending. I hope that you've learned something. If you have any questions about CodeArtifact, about using AWS, we have people in the chat that'll help. They'll try to answer your questions or find the people who can answer your questions. Again, thanks for tuning in, and I hope you've enjoyed hearing me talk as much as I've enjoyed talking to you about AWS CodeArtifact. Thank you.